Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Donuts by MD88 Keys, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Digits on an arrow sum to the number in the attached circle. So for example, if you had 5, 1, 2 here, this would have to be 8 because the digits along the arrow must sum up to the digit that's on the circle. Digits in a cage do not repeat and sum to the number given. So that means these 8 digits cannot repeat and they sum up to 44. These 8 digits cannot repeat and they sum up to 36, etc., etc. And gray shaded squares must be even numbers. So these have to be 2, 4, 6, or 8 here. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. We know all of these are the sum of 3 unique digits, so they all must be 6 through 9 here. The squares are okay, hold up. This square is... So these are the digits 1, 2 through 9 because they're 8 digits adding up to 44. These are the digits 1 through 8 because they're adding up to 36. So the thing is, these 3 digits must match this digit or these 4, right? Because they cannot be the same as these digits because they're in the same cage. Now the question is, which digits are they? This digit actually definitely has to be one of these digits here because it's an even digit and it's obviously not missing in the digits 1 through 8. So this is missing a 9. So we're missing a 9 here. We're missing a 1 here. Here, okay, so this is probably easiest. We have 45 minus 39, which is 6, which means this has to be a 6, which means this must be a 1, 2 pair here, which adds up to 9 here, because 6 can only add up to a single digit when it's added up together with 1 and 2 for 3 digits. So that's definite. Remaining digits of row 5 are 3, 4, 5, 7, 8. Okay. This 44 is missing 1. This 41 is missing a 4. So this cannot be 4. It's 2 or 6 then, because 8 can never be added up with 2 other unique digits to add up to a single digit. This is 7 or 8, so this is guaranteed to have a 1 here. So this is either 1, 2, 4, 1, 2, 5, or 1, 3, 4. I'm not sure which. Remaining digits in box 5 are 3, 4, 5, 7, 8, and 9. This is all the even digits again. This cannot be 1, 3, or 5. So we're guaranteed a 1 can't be in this cage because we're missing a 1. So this has to be 1 here. So it's 1, it could be 2, 4, or 4, 3, or 2, 5. We're not sure which. Okay. We have a 2. This is 2 or 6, and it's adding up with. If this is 2, this has to be either 1. Oh, it could be 2, 3, 4. Never mind. Never mind. 1 cannot be here. This is 2, 4, or 6, and it must be with one of these 2 digits then also. So 3 out of these 4 digits are here. 3 out of these 4 digits are here. So, okay. That's interesting. So these, obviously 1 can't be here. And since 1 is here, this can't have a 1. So we know 1 is guaranteed to be here in a box 4. That means this can't be 1 in the 44 here. We're missing 1 here. Well, yeah, you're missing 1 anyways. So 1 has to be one of those 3 there. 1 could be any of these 3 specifically. So these 3 digits have to be exactly the same. Well, that's not true because one of these could be 1. Let's do these 3 digits. These 3 digits are the same as these because 1 cannot be in this cage and it's definitely there. So all 3 digits here are the same as these 3 digits. Let's see. This one is guaranteed to be one of these 2 digits, so it's not all 3 of these. Hmm. 9 cannot be here or here, so 9 in this cage has to be one of these 2. Which means this cannot be 9. Okay, so that's good to know. And this has to have a 1 to add up to 6, 7, or 8, because you need 1, 2, 3, 1, 2, 4, or 1, 2, 5, or 1, 3, 4, adding up to 6, 7, or 8. So this is guaranteed to be 1 here. So this cannot be 1 here. Okay. 9 cannot be here, and there must be a 9 in this cage. So this is 9, which means this cannot be 9. So 1 in this arrow has to be one of those 2, which means we have to have 1 be one of these 3, or one of these 2 digits. So obviously 9 cannot be here. One can't be here and cannot be here. The 1 on this cage has to be one of those 3. This is 6, 7, 8, and therefore this cannot be 6 with 1, 2 here. So this has to be 2 there. That eliminates 2 from being there. Two cannot be any of these cells, so 2 has to be one of these 2. because we can't have repeats in a cage. 2 eliminates 2 here. So that's 1, which makes that 2. That eliminates 1 in this cage. Where is the 1 in this cage? It has to be here. And this must be 2, 3, and 4 to add up to 9. So that's 9. This is not. This is 2, 3, 4. 2, 3, 4. Where is 9 in this cage? Can't be here, can't be along the arrow, so it must be one of these 3. Interesting. Remaining digits of row 2. We have 1, 5, 6, 7, 8. Obviously, 1 cannot be either of these 3. We have a 5, 6, 7, 8 quadruplet in box 3. That's interesting. So that means this can't be 5 here, because the 5 is guaranteed to be one of these, and the rest of the digits in the box are 2, 3, 4, and 9. No 2 or 9 here. So this must be a 3, 4 pair, which eliminates 3, 4 in the rest of the row. This is the only place for 9 in the cage, so this is 9, which makes that 2. This has to be 1, 5, and 2 to add up to 8, because no other combination works for this digit. So this is 1, 5, and 2, adding up to 8. So no 5 or 8 here, no 5 or 8 here. The 6, 7 pair eliminates 6, 7 in the rest of the row. That's interesting. So we have 3, 4, 3, 4. We need the other 3, 4, which cannot be here, because both 3, 4s are here, and we need the 8 in the cage. So this is 8, and this is the other 3, 4. There's no 8s here, no 8s here. We need to have 8 as one of these 3. One can't be here. Can't be here. Where is 1 in box 4? It must be there. Okay. So this is 2. It could be 1, 3, 1, 4. But 4 can't be here, so 1, 4 or 1, 5, adding up to 6, 7, or 8 here. Two is one of these digits here, which means this cannot be 2. This can't be 2. If this were a 2, the problem is it would have to appear somewhere in this cage and would have to be here, which is not possible. So this can't be 2, which makes that 4, which makes that 3, which makes that 2. That's interesting. That can't be 2. It's 4 and 3 adding up to 8. So that eliminates 8 here. No 8 here. This is definitely has a 4 in it. 4 cannot be here or here. 3 eliminates 3 in the rest of this row. So it cannot be 1, 3, 2, adding up to 6. 4 is here, which means this can't be 4. These can't be 4 because of 4 in the box. These can't be 4 because of 4 is in the column. So this is 4 here. 3 cannot be here or here. 3 has to be in one of these cells, which means we cannot have, well, okay, we already knew that. This can't be 3 or 4. So remaining digits here are 1, 5, 6, or 7. And this can't be 1 because of 1 in the row. Remaining digits of column 2. We have 5, 6, 7, and 9. 9 cannot appear in this 36 cage. Remaining digits of this cage have to be 5, 6, 7, 8. There's no 8 there. We have a we need 4 also. The 4 has to be one of these two, which eliminates 4 in the rest of the column. So that means where's the 4 in box 8? Can't be on this 41 cage because we're missing just the 4 there. So 4 has to be here, which makes that 1, 4, and 2, adding up to 7. That eliminates 7 in the rest of the column. This 1-8 pair eliminates 1 and 8 in the rest of the box. So this can't be 8. Whereas the 8 in this 36 cage, it must be there. Okay. Um, 8 has to be in one of these two cells. Nine has to appear in one of these 4 cells. So that means the 9 in column 4 must be one of these 2 cells, which eliminates 9 in the rest of the box. Hmm. 2 has to appear in one of these 2 cells here. Because it can't be here, can't be here. So this is 2, 5, 6, 7, 9, and 2, 5, 6, 7, because it must match these cells, and this must be a 2, because this can't be 2. So that eliminates 2 from being there, so this is 2 there, because these 3 cells match these 3. That eliminates 2 from being there, so 2 has to be here. Remaining digits in column 4 are 5, 6, 8, and 9. And 9 can't be there, because 9 has to be one of these 2. So this corresponds to that digit. Okay. This can't be 5 because of 5 in the column. Oh. Where is 4 in row 5? It must be one of these 2 digits, which eliminates 4 in the rest of the box. So this can't be 4, it's 3. That eliminates 3 there, so it's 4, which makes that 3 there. Therefore, there's no 3 here, which means one of these 2 is a 3. 4 eliminates 4 here, so it's 5 or 6 there. This can't be 5 or 6, it must be 4 because of the 5, 6, 7 triplet. One of these 2 digits is a 7, which eliminates 7 in the rest of the column, so no 7 here, no 7 here, which means this can't be 7 either. Seven cannot be here. We need a 7 in this cage, so it must be one of those 2, which means 7 has to be one of these 3. We also know one of these, this 7 can't be in the cage here, but it needs to be in the cage, so one of these is a 7, which eliminates 7 in the rest of the column, so this can't be 7. That's 6 and 7 there. 6 eliminates 6 in the rest of the column here. 7 eliminates 7 here. Okay. This digit must match one of these digits here, and it cannot match here, so it must match that one. Therefore, because it can't match 2, it can't match these digits at all, and it's guaranteed to be part of the cage because this cage is only missing a 4. So this must be 5 corresponding to that. So it's 5, which makes this 9, which makes that 8. 5 eliminates 5 here, so it's 6, which eliminates 6 in the rest of the cage. This is a 5, 7 pair, which eliminates 5 and 7 in the rest of the column. So there's no 5 here, no 5 here. 9 eliminates 9 here, so that's 6, which eliminates 6 here, so it's 9. So none of these could be 9 there. This has to be a 7 remaining in this cage, and it can only be there. 5 eliminates 5 there, so it's 1, which means this can't be 1 there. There's no more 7s here, and the 1 remaining in row 9 has to be there. Again, no 8. 9 here eliminates 9 in the rest of the box. So where's 9 in the cage here? It must be there. That leaves this as not 3. It has to be 5 or 7 here. This can't be 3. It's 4, 5, or 7 there. And 4 eliminates 4 here. So where's 4 in row 4? It must be there. 1 eliminates 1 here, so it's 8 and 1. And the rest we do with just normal Sudoku, because these are really restricted. Remaining digits of box 1 are 3 and 6. And this can't be 3 because of 3 in the row, so that's 6, which makes that 3. That means this can't be 3 here. Where's the 3 in box 4? It must be here. Remaining digits of box 1, we have 5, 7, 8. No 7 here. No 5 here because of 5 and 7 in the rows respectively. Remaining digits of column 3 are 5, 6, 7. And this can't be 5 and 7 for the same reason. Remaining digits of row 6, we have 6, 5, or 7. No 5 here, no 7 there for the 5 and the 7 in the column. Remaining digits of row 1, we have 5, 7, and 9. Remaining digits of row 3, we have 2, 5, and 7. Well, 2 can't be here, so 2 must be here. We have a 5, 7 pair in column 6, which eliminates 5 and 7 in the rest of the column. So this is 9, this is 3. No 9 here, no 3 here. That means this can't be 3 or 9. This can't be 3 or 9. It can't be 5 or 7. It's 6 or 8 as a pair. That forces where's 9 in this box? It has to be here. So that's 9, that's 3. Remaining digits in row 9 are 6 and 8. 8 eliminates 8 here, so it's 6, which makes this 8, which makes that 6, which makes this 7, which makes that 8, 5, and 6. 5 eliminates 5 here, so it's 7, which makes that 5. 5 eliminates 5 here, so it's 7, which makes that 5. 7 eliminates 7 here, so it's 5, which makes that 7, which makes this 5, and that's 7. 5 eliminates 5 here, 6, 7, 4, and 5. And the remaining digits here are 3 and 9, and we have 4 and 8. And that's how you solve it. Yeah, fairly straightforward. Interesting how these donuts worked. Yeah, I'm not really actually used to doing cages with whole sections being essentially equivalent of these potential digits, right? So that's interesting. I guess I could have done something similar. Well, I did do something similar. I didn't color it like I did here. It was interesting. An interesting, nice little puzzle. Well, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.